Welcome to the video lecture series of data structures. For today's topic is singly linked list deletion. Hi, this is your instructor Janice Shah. So let's begin with today's topic. Students, we are going to learn about the singly linked list deletion. See, this is not a normal deletion where we are just going to delete any node. What we are going to do is, here the x is not a value. Here x is an address. So we already get the first shows the first pointer of the linked list, that shows the starting or beginning of the linked list. So we can understand from which linked list we need to delete the value. We get that from the first pointer value. Okay. If a first is 1000, then your computer will understand that I need to check a linked list which is starting from the 1000. Your first is 50, then your computer will check that I want to delete something from which the link is starting from the 50. Okay, so it will just go towards the 50 and then start the traversing of in the linked list. Fine. So here in deletion, students, we are not going to return anything. Okay, so what we exactly going to do over here? See, if you remember my example of the stack of the chairs, where if you want any chair, you will just pull out from the stack, take it and sit over there. Pull out from the stack, take it and sit over there. This is what I call the stack of the chairs. This is what I call the stack of the chairs. Students, I usually call it as availability stack because it is same as this. All the empty spaces of the chairs represents the empty memory spaces, empty nodes. Fine. Now what happens? If you are a good and well-mannered students, then what you are going to do is, when your task is completed, when your lecture is completed, you will take your chair and put it again on the stack. You will take another student will come, take its chair, again pull it inside the stack. Okay. So this same thing happen with the memory. When you do not need any further node, after deletion of the node, what you need to do is you just need to free it. Free, that means again that node will set to the availability stack. We will see these steps also. So let's begin with the first one, the deletion operation. Usually we are performing the deletion operation. What condition we are going to check is underflow. Yes, sir, are you going to check the underflow condition in linked list? Yes, I am, because if a linked list does not exist, what you are going to delete? Fine. And you already know about the condition, because in our all previous three insertion algorithms, we have seen that when the linked list does not exist, what happens? Your first pointer is pointing to null. So how can you say that, sir, my linked list does not exist? Students, when your first pointer is pointing to null, then you can easily say your linked list does not exist. So this is my first condition to check the underflow. If f first is equal to null, then you can write that linked list does not exist and you can go return. So here the return is a statement only. I'm not going to return anything. That's why it's a procedure, not a function. Next, if first pointer is pointing to null, then it's known as underflow. If is that not so, you have some values in the linked list. Then what to do? You have to search for x. See, what is x? X is a value? No. No, x is not value, students. In this example, x is a address. That means you should not write like this info of new or info of first. You have to take the first. You have to check whether the first value is x or not. Okay, because x is not a value over here. X is the address of a node what you want to delete. Okay, so whatever the node you want to delete, its address is x over there. Fine, we just need to identify, or we just need to find out the x. Okay, so how we can do this? Let me show. See, this is my linked list. This is just for a concept understanding that what we actually want to do. Okay, so this is my linked list. So the values like 10, 40, 50, 60 and 80 are there. The x is a pointer which is pointing to 60. So what I want to do is, I just want to find out the x over there. So how can I do that? Students, to move in the linked list, what we do, we just need to do traversing operation. Correct? Usually we take the save pointer over there, For the better understanding, I am going to taking the temporary pointer, which is known as temp. Okay, because sale is also a temporary pointer. What is the algorithm? I am going to take a temp pointer, which is known as the temporary pointer, and initialize it to the first. So here it is. Temp is pointing to first. So this is my step number 3. Step number 2. I am just initializing my temp to first. Next. So after initializing students my temp to first, my process will start of finding x over there. So what happens? I'm going to finding the x by writing that until and unless temp is not equal to x, until and unless the temp value is not equal to x, or and the link of temp is not equal to x. See, you have to find x, you have to search x, but it's not like that. You are just searching x in the whole linked list and x is not there. Then what to do? You just move out from the linked list. And if you move out from the linked list, at that time, last time your link of temp becomes null. So this is not going to be happen over here. So what we need to do is we just need to write if until repeat our while loop until and unless the link of temp is not equal to null, and also check the temp is not equal to x. Both conditions must be true. So let's begin the search of the x. So in the search of the x, see the temporary pointer is there. Temporary pointer is there. Okay. What I'm going to do is I'm going to take one predecessor pointer. So why we're taking the predecessor pointer? Let me show you why. See, if this is a node. See, if I want to delete 60 students, if I want to delete 60, I want name of the 60. Okay. Then after that, I want to connect the link of 50 to 80. I need to connect link of 50 to 80. For this, I also need name of 50 because one pointer is assigned to 60, one pointer is assigned to 80. How? Because if I have only one pointer, that is temp, and I stop temp at x, then the name of the 60 is temp and the name of the 80 will become link of temp. But what about the 50? So for this particular 50, I am taking another pointer predecessor which is always followed temp. If temp is at 40, predecessor must be at 10. If temp is at 50, predecessor must be at 40. So predecessor in the thing, it is just following temp. Okay. So now what happens? See, I am just assigning temp to predecessor. Sorry, predecessor to temp. Okay. See, here it is written over there. We need to repeat up to step number 5. So this is my step number 3 where I started my loop. Step number 4 to take pred to temp. So I am taking another pointer pred to temp. And the step number 5 is temp to link of temp because we need to traverse it. Okay. So let's start the traversing. So temp will move further. Temp will go out and pointing to the 40. Now again check the condition. Is temp is equal to x? No. Link of temp is equal to null? No. So what happens? What happens? Your pred will point to temp. So your pred move further and assign to temp. Next, so temp is equal to link of temp. Step number 5. Step number 5. Temp arrow link of temp. Temp will move further and go ahead dot 50. Now again check is temp is equal to x. No. So again move further. Here it is. Temp will move further. Pred will move further. Now check. Temp is equal to x. Yes, you are correct. Where? Where x? I didn't write x over there. I didn't write x over there. Okay. So this is my temp. This is my pred. Students, you reached to the end of the linked list. Still, you didn't find any x over there. Okay. Now, link of temp is not equal to the condition becomes false. So, after completing these all 5 steps, 3, 4, 5, 3, 4, 5. Okay. Temp to link of temp and pred to temp. After performing all these steps, you didn't find any x. So, step number 6 is if temp is not equal to x, you didn't find any x. So, just write no node found and then return. But if it's not like that, you already find the node when at the starting position. This is the first condition in the deletion. That first you need to check whether the temp is x is exist or not. We have already did it. Then if x does not exist, then we can write like node is not found. Second condition, we need to check x at the first position in the beginning. If x is equal to first, After initializing the temp and period, if you find that x is equal to first, that means you need to delete your first node. Then what to do? It is very much easy, students. If you are going to delete your first node, if I am going to delete 10 over there, then first just need to move to 40. If I'm going to delete the 10, then I just need to move first from 10 to 40. Fine. So now my first pointer will move from 10 to 40. And always linked list known from first to null. Okay, linked list, the size of the linked list from first to null. Here already the node temp or x, whatever you call, is out from the linked list. So it is deleted. We can consider it is deleted. Fine. It is pointed by temp and x, so its name is temp or x. Now, next condition. If it's not like that, now this is the correct one which we are looking for. I want to delete search 60. What should I need to do? Okay, let's see. First, assign this period over there. Period will be pointed to temp, and temp will move further link of temp. Again, period to the temp will link of temp. Period to the temp will link of temp. Students, now let's see. Now temp is at x. Temp is at x. So you are not going to move further. So what to do? To remove the 60, I need to take the link of 50. Link of 50 will pointing to 80. Now I must have some pointers over there. So it's pointing to 80. The name of the 80 is link of temp. Okay, and the name of the 50 is period, but the link of the 50 is known as link of period. So what I see, this link is known as link of period. So what I need to do, I just need to move, and this link is known as link of x. So link of x or link of temp. The link of the 60 is known as link of x or link of temp. You can say anyone, because at the 60 we have both pointers, temp and x, both are there. Okay, so you can call 80 by two names, either link of temp or link of x. So what I need to do is, I just need to link else part. If it's not in the first, then just x part. Else link of period is equal to link of x. See, link of period is equal to link of x. This is a main step. Now your link list like 10, 40, 50. After 50, directly move towards 80. After 50, directly move towards 80. Correct? So what happens over here? We have just reached to a destination. Now your 60 does not have anything with 50 or 80. So what to do? At the last point, our node is deleted. So this is the main step. After deleting of the node, you just need to restore it to the availability stack. So last time it returned to the availability stack. How to do that? See, this is my new node. Each and every node must contain data and pointer. Yes or no? Yes. So this is my temporary node. This is my x. The node, whatever I deleted, it contains two different pointers, temp and x both. So I just need to connect link of x or temp to available pointer. The step is link of x arrow avail. So after assigning link of x to avail, which will become my topmost node. This is stack, okay students, this is available stack representing by linked list. Now let me know which one is my topmost node. Avail, no. Temporary or x is my topmost node. So we need to move avail to x or avail to temp. So this is my last point, that is avail arrow temp. So now avail pointer is moved further and pointing to temp, and this my availability stack is completed. Such like this, your whole deletion operation successfully completed. What we have seen over here, we have seen that how can you delete the node. Different conditions are there. We take temp, we take period. First condition is that if we want to delete something, we need to check the underflow condition. Second one is if whatever you are going to delete is not there in the list. Okay, so that's node not found. Third one is if your value is there but is just as a first position. Okay, this one is for if x is equal to first. If x is equal to first, step number 7, then you just need to write like this: first arrow link of first. You just need to move your first pointer to the next node. And the last one is else link of period to link of x. Such like this, you can perform the deletion operation. The last step is return. Just write return. So that's it for the today's lecture, students. If you have any doubt, then please feel free to ask me. Thank you so much.